A few weeks ago, I made a video about data science books recommendation on the channel. Although many of you loved it, I was still unsure if I was already aware of all the best data science books out there, and this uneasy feeling motivated me to take a more data-driven approach to explore a little bit what kind of data science books are available out there. So I found a dataset on Kaggle that contains data on nearly 1,000 data science books on Amazon, including the ratings, the price, the number of pages, and other characteristics. We'll be doing 3 levels of analysis, what I'd call basic, intermediate, and advanced level. So on level 1, we'll do some simple exploratory data analysis to answer questions like, do more expensive books have better reviews? Is it always true that longer books are more expensive? Or what are the best Python-related books, and what are the best machine learning books based on review stars? Moving on to level 2, we start getting a bit more fancy. We want to find out what are the main types or main categories of data science books out there based on the book titles. We'll be using k-means for clustering the book titles, and in order to do that for text data, we use an NLP technique called TF-IDF, or term frequency inverse document frequency, to convert the text into numeric features. And don't worry, we discuss those concepts along the way. And finally on to level 3, which is not for the faint-hearted. We scrape the Amazon reviews for these data science books to further enrich the data, and we'll be using an advanced text summarization model to get a text summary for each book. The main motivation for this is that if you're like me, you might often spend hours reading book reviews to see what people are talking about the books, so why not have a smart machine learning model do this for us? It's actually very simple to implement. This video is also to demonstrate a powerful collaborative notebook tool, Deepnote, who has kindly sponsored this video. Without further ado, let's get started. Alright, let's first go to Kaggle and download this data science books dataset. It's rather a small dataset, and we'll be exploring it in a bit. So to start off, if you're not yet familiar with Deepnote, it's a free online data science notebook mainly focused on real-time collaboration. It's a new kind of notebook that looks better and integrates better with other tools like Git, Google Drive, and so on. You can say overall Deepnote is quite similar to Google Colab, but Deepnote is geared more towards real-time collaboration, and its main aim is to eliminate all the friction when it comes to sharing notebooks, sharing data, and keeping a version history while working together in a team. I also really appreciate that it allows you to create beautiful, rich text in your notebook, adding comments, callouts, and to-do lists, much like what you can do in a note-taking app like Notion. After you finish your project, you can also publish a notebook and customize the final look of your project in the form of articles or apps. You can choose to show or hide any cells, which is great because sometimes you might want to hide the gnarly code cells from non-technical audience like your mom, and then you just copy the link and share it around like how you'd share a website. I think it's a great option for passion projects, for quick prototypes, and team projects where you want to collaborate with others and show your output in the most accessible and presentable way. To get started with Deepnote, let's go ahead and click on the Get Start button, and here you can choose to connect using your Gmail or GitHub account. In my case, I'll sign in using my GitHub. I'm using a free tier which allows you to have up to 5 projects at a time and up to 3 team members. I think the only small inconvenience with the free tier is that your cloud-hosted machine will go offline after I think 15 minutes of inactivity, and you have to spin it up again. But I believe it's not a major thing. Alright, here's how the interface looks like. On the left sidebar, you can find a few sample projects, and I'll go ahead and start a new project. You can choose to import an existing notebook from your Git repo or Google Drive. There are also other integrations that you can add over here in this tab. The interface looks very similar to a normal Jupyter notebook, but everything is run on the cloud-hosted machine, so you don't need to install anything locally. And if you want to run the notebook on your iPad or your phone, it doesn't really matter. So let's make a small to-do list here to keep track of the analysis that we want to do. Now let's import a few necessary libraries here to start with. So NumPy, Pandas, Matplotlib, and Plotly Express. And to upload our dataset to Deepnote, we just need to add a dataset over here. Then we can either query this dataset with SQL and save it in a data frame, or you can also copy the path to the file here and read it as usual with Pandas. Let me go ahead and do that. And if we print out the DF here, we can see a nice overview of the data, including the distribution of the data in each column and also the percentages of missing values in each column, which is quite handy. We have in total 946 book titles, and I believe that it contains many cool data science books here. And here we can see we have the book title, the author, the price, number of pages, average reviews, number of reviews, the percentage of 5-star, 4-star, 3-star, and so on. We also have information about the dimensions and the weight and the language, the publisher, and also the complete link to the Amazon page. So quite handy if you want to check it out. Now let's do some exploratory data analysis, which is level 1, to answer a question like, do more expensive books tend to have better reviews? What we can do is to create a scatter plot that plots the book price against the average reviews. In this case, I'm using Plotly Express to quickly create the scatter plot with the x-axis being the price, the y-axis being the average reviews, and maybe you can also add the size as the number of reviews just to see how popular a book is. However, on Deepnote, there's an easier way to do this. If we click on the plus button here to add a new block, if we go down, we can see that we have an option called Chart, Visualizing Data Frames. If we select that, we have a new option that basically gives us the option to create different types of charts, and we can also specify the dimensions here. For example, I choose x-axis as the price and the y-axis being the average reviews. Then we can basically have the same scatter plot as we had before. You can see that there's actually no clear relationship between the price and average reviews. So good books can also be very cheap, or it can be very expensive. Similarly, if we do the same exercise but plotting the price against the number of pages, we can see that there's some positive correlation here. So longer books tend to be a bit more expensive, which makes total sense because it costs more time and effort to write those books. Now let's try to answer the question of what are the best Python books and what are the best machine learning books. We can do this by a simple rule-based method. So we select all the books with the titles containing Python. And now let's select the Python books with most reviews and have highest average rating. We can do this by using the nlargest function. For example, if we want to only select the top 7 books, and here we can select the columns that we want to use to sort the data. The reason why we want to sort the data on both number of reviews and average reviews is because some books might be not very popular and they have very few reviews, but they are very good reviews. So these cases might be more prone to bias. And in this 7 best Python books, we have here Python Crash Course 2nd edition. I'm not familiar with this book. We have Automate the Boring Stuff with Python, which is very cool. It's a very good book. I'm also very happy here that we have in the list Python for Data Analysis, which is a book that I recommended. So it's a relief that I actually recommended a good book. And similarly, how about the best machine learning books? And we can do basically the same thing, right? And here we can print out the top 7 machine learning books. We have some deep learning books. We have the 100-page machine learning book, which I didn't really enjoy so much. We have pattern recognition and machine learning, which is a very classical book. We have a book about reinforcement learning. So overall, it's quite interesting and informative, but I think it really depends on your need what would be the best books. Alright, moving on to second level. We are doing text clustering with TF-IDF and K-means clustering to answer the question, what are the main categories of data science books in this dataset? And with this approach, we can automatically classify the books into different categories without having to go through the 1000 book titles by yourself and come up with the classification rules. As you may already know, clustering is an unsupervised machine learning technique. It is a task of dividing the population or data points into a number of groups such that the data points are more similar to other data points in the same group and dissimilar to the data points in other groups. This method is very useful for understanding the structure of the data, and there are many clustering algorithms out there. One might work better than others for particular types of data. But for this project, we're going to use one of the most simple and popular ones, which is K-means. K-means is an iterative algorithm. You just randomly initialize the centroids or the centers for your clusters, and then we simply assign each data point to the nearest centroid. We calculate the mean of the location of all the data points that belong to each cluster, and then move the location of the centroids to that average location. This is the first iteration on this example. sample dataset, and you can see that the clusters don't make much sense because it's totally random. And after several iterations, the centroids will naturally be shifted towards the true clusters in the data, and at some point the position of the centroids will stop changing. In rare cases, this process may not converge, but generally it's a very smart algorithm, and I think it works reasonably well in most cases. Now we got this, but we have a small problem here. In our case, we are clustering text data, which is a bit more tricky than the usual numeric data, so we first need to somehow convert the text into numerical representation that can be used and understood by machine. In a fancy term, this is called text vectorization. People have come up with multiple methods to do this, from basic ways such as counting the word frequency in the text and use each unique word as a feature, to more advanced methods like word embedding that use shallow neural network on large text corpus to learn the underlying context of the words. However, features in those methods and what they mean are harder to interpret. And in recent years, we also have large transformer models that encodes text into huge embedding vectors. We'll look at one of those models in level 3 in this video. For now, we use TF-IDF, which is a popular frequency-based vectorization method. It's simple, but for sure better than the simple count vectorizer. Let me take a second to try to explain this technique. So our aim is to convert the text, and in this case the book title, into an array of numbers. And the array would contain the value for each word that ever appears in one of the book titles. 0 means the word doesn't occur at all in this current title. Low value means the word exists in a title but is not very important for the overall meaning of the title. And the higher value means the word is more important for the overall meaning. So how does TF-IDF determines those values? It does this by multiplying two factors together, term frequency and inverse document frequency. The idea is quite simple. The first parameter is a local parameter. We calculate the frequency of the word within the document, or in this case, within the book title. In the book title, the best Python book for Python lovers, the word Python occurs twice, while other words occur only once. So Python has term frequency of 2 and other words have term frequency of 1. Overall, we are assuming that Python is a more important feature because it occurs more often in this title. And the second parameter in this formula looks more globally, looking at how rare the word is across all the documents. We measure this by taking the inverse frequency of the word in all the documents. For example, if we have another book title named The Best R Book, we can see that the word best is quite popular. It appears in both book titles, so we can assume that words like this are probably less important. So multiplying these two terms would give a quite good measure for the importance of the words, and it assigns higher value to the more descriptive and informative words and lower value to the unimportant but maybe more commonly occurring words in the English language. So from scikit-learn, let's import the TF-IDF vectorizer. If you haven't installed scikit-learn, you may have to do so, and then we can initiate the vectorizer object here using the stop words being the English language. Stop words are words like you, me, at, the, with, etc. Those are the words that are generally not interesting for NLP tasks. And let's also specify the n-gram range here from 1 to 2, because in our book titles we usually see words like data analysis or machine learning or data science, etc. Those are the words that have 2 words. So the n-gram here basically says how many words we want to put together at a time. And then we can just use the vectorizer to fit and transform the title into a vector. X here is just basically a huge array that represents each book title. Now to implement k-means, we also import k-means from scikit-learn, and a small challenge with k-means is that we have to specify the number of clusters that we want to create, and we don't know in advance what is the optimal number of clusters, so we have to find it out ourselves. So the strategy is that we just assume a minimum number of clusters, let's say 2 clusters, and the maximum number of clusters, let's say 10, and for each value in those potential number of clusters, we'll perform k-means clustering, and then we'll calculate the sum of squared distance, or inertia as how it's called in the scikit-learn library. It is the sum of squared distance of the data points to their closest cluster center, and I'll just append those sum of squared distance into an array. Oops, I forgot to import k-means. And then after we've performed all the clusterings for each possible number of clusters, we plot out the sum of squared distance, We can see that the more clusters we have, the lower the sum of squared distance is. It makes sense, right? Because in extreme case, if we make one cluster for each individual data point, then the sum of squared distance would be technically 0. With the elbow method, we want to find the optimal number of clusters that have the lowest sum of squared distance. We can see that around cluster 6, the sum of squared distance starts declining more slowly, so we can expect that 6 is the optimal number of clusters. However, k-means is not deterministic, so if you run the code again, you might see a slightly different graph. For now, we'll just choose 6 as the optimal number of clusters, and then I'll pass that into the k-means model. To get the prediction labels, it's quite simple. We just get the labels out of the model and then zip the labels with the title in the data. And here you can see that which cluster the books belong to. Now you might be thinking, okay, what are those clusters actually mean? That's a good question. One way to do this is just to print out the top terms per cluster. However, it's a little bit less interesting. I prefer to use a more visual way to do this. We can create a word cloud for each book title cluster. It's very simple. For each cluster, we obtain the text from all the book titles within that cluster, and then we'll create a word cloud out of it. Here I just randomly put some arguments here. You can customize it if you want, and then we just plot those word clouds. To put all the word clouds together to easily compare them, I'll use subplot to make 2 rows and 3 columns because we have in total 6 clusters. And ta-da! We can see that indeed for each cluster we have different kinds of topics. Cluster 2 is all about programming and Python. Cluster 5 is all about deep learning, Python, neural network, PyTorch, and TensorFlow. So it's quite interesting to look at those clusters, and we can print out here what exactly are the book titles within those clusters. In Deepnote, you can also create an input field. For example, I can create a drop down for choosing the cluster number. So this can be interesting for creating a dashboard on app later. And with this k-means model, you can use it to predict or classify any book titles to see which cluster it belongs to. For example, here, if I just type TensorFlow Deep Learning, it will classify it as the cluster 1, which is all about deep learning. Now on to the next level, which is the most challenging level. We'll be scraping Amazon book reviews and then try to create a summary of the reviews for each of the book. So first of all, to scrape the Amazon book reviews, we need the URLs of the review page for each of the book. The good thing is that in the data, we already have the complete link to the product page. So we can use this product page to adapt it to the old review page. So if we compare the 2 URLs, we can see that the review page has the product reviews, the product number, and then we have the a query string here. So I just go ahead and write a small function here to translate the product URL into the review URL. Basically, just try to split the product URL and take the necessary parts and then paste all the parts together. Now with this function, we can apply it on the complete link column to create the review URLs column. And we just exclude all the empty review URLs because there might be some problem with that, some different structure, etc. For the Amazon review scraper, I actually found the code from Jeff James' GitHub, since it often takes some time to experiment and build a working scraper, so I just adapted from his code. So kudos to Jeff James for creating this. I wouldn't go into the code to explain everything what's happening here, but basically we're scraping the first page of the review page and put everything together in a data frame. After we are done, we got 4,500 reviews in total, and with this dataset you can use it as a toy dataset for example, sentiment analysis. But for this project, we try to create a summary for the reviews for each book. Text summarization is the process of shortening a set of data computationally to create a subset or a summary that represents the most important or relevant information within the original content. Thank you, Wikipedia. Now let's merge all the reviews together for each book. We can just do a simple group by here by the book title and concatenate the reviews together. There are two types of text summarization, extractive and abstractive. Extractive text summarization, just like its name, basically extracts the most significant sentences of the text and creates the summary. It doesn't change the sentences themselves in the original text data. On the other hand, abstractive text summarization is a little bit more advanced because it can interpret the context and paraphrase the text in a new way. So the summary is generated by the model, not just extracted from the original text data. In the scope of this video, we'll be doing extractive text summarization, and I think for the review data, this should be sufficient. Hopefully, we can extract the most important points people talk about and ignore all the useless rambling. We use BERT model. BERT is a transformer-based language model trained by Google that came out in 2018. To implement the extractive summarization using BERT, we can use a library called BERT Extractive Summarizer, which implements a paper by Derek Muller that aims to develop a model to summarize lecture content. It looks quite interesting, but I haven't read too much into the details. But if you want to go down this rabbit hole and understand how this model works, you can check out the link to the original paper here. Now we can load the BERT Summarizer model. It can take a few seconds. I'll first create the summary for one random book in our dataset. In the arguments here, we can specify either the number of sentences we want our summary to be, or use a ratio or the minimum length or maximum length for the summary. And now let's print out both the summary and the original text. The text is now only in one line. I'll just quickly wrap the text so that we can see the full text. I don't know about you, but I think the summary looks pretty decent. Although sometimes the flow of the sentences is a bit weird, but I think it does a pretty decent job at removing the noisy information from the most important one. If you want to experiment with abstractive summarization, recently OpenAI has made GPT-3 model available to the public, which is cool, and I bet it will perform this task very well, but the API is a little bit pricey, so it's up to you if you want to play with it. Alright, after all the blood and tears, hopefully we are happy with analysis. We can finally publish this notebook to show off our work. There are two options for publishing on Deepnote. One is publishing as an article and the other one is as an app. If we choose article layout, the article will look quite similar to a normal notebook. We can choose to remove certain cells or hide the code or the output from the cells. The other layout is the app layout. This is a case where you want to mostly show the visualizations in the form of dashboards or app. And interestingly, on Deepnote, you can also freely arrange the elements of the dashboard, moving them around to create your own favorite app layout. This makes it very easy to customize our apps. Let's say here we want to create a dashboard to show some exploratory data analysis on our data science books dataset. We can keep only the necessary cell, and then using this link, you can share it with anyone. I hope you enjoyed this project video and got to know a lot more about data science books. If you decide to give Deepnote a try, let me know in the comment section what you think about it. I've put the Deepnote link to this project and the GitHub repo with the full code. If you found this video helpful, please do subscribe, and you might want to check out this video over here and other project videos on my channel to get more inspiration to build a great data portfolio. Thank you for watching. Bye bye!